Thank you for joining me today. I will go through the term project. This is our AutoCAD file. This is called elevation, and this is called plan, and these are the side views. You have to read your file or your drawing carefully. These trusses started at axis 1, 1. Axis 1, 1 is here, so we have truss. And make sure you understand this is the first column and this is the second column at the two sides. This side and this side. In between, we have 1, 2, 3, 4, 5, 6, 7 columns. If you go back here, you will find the 7. 1, 2, 3, 4, 5, 6, and the 7 columns. That makes sense. Then the repeated truss will be without columns until you reach to axis 5, 5. The repeated truss is here without intermediate columns. Only columns, 2 columns at the two sides. That's it. After 5, 5, we will have at the same location 5 dash and the 5 dash. We will start another structure, which is called the frame, with 3 columns, 2 at the two sides and 1 at the intermediate distance. So if you look to the frames at axis 5 dash, 5 dash, you will find 3 columns, 1, 2, and 3. And this frame is repeated until you reach to axis 11, 11. At axis 11, 11, we will have another frame with intermediate columns, 1, 2, 3, 4, 5, and 6 columns. If you count here, we have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. 3 on this side and 3 on the other side. Looks like also we have a mistake here. We have a little mistake. This one should be symmetry. This is the mistakes that can happen in the real life project. You have to contact the engineer or the designer and they say, hey, we discovered that we have mistakes. So you have to make sure. Here you go. This one looks good. It's symmetry. Does that make sense? So, but you don't need to do this change until you have approval from the designer. Does that make sense? Here you go. So let's start to figure out the quantity takeoff calculation for each part. I do recommend to follow up this table part by part. Let's start with the columns of trusses. So I will write here column of trusses. If you would like to highlight or change the color, you have this option here. You can change what you want. It's up to you. If you would like to change the size of the text, if the size of the text became bigger than the cell size, you can come here and double click. It will be changed according to the size. The columns of trusses is made from W16 by 100. You can make copy, by the way. Here you go. And you can make it bigger. So this is the size. This is the size of your, we can move it here and write here the size or member size. This is up to you. I will not ask you for a specific format, but it's up to you. What is the length? What is the weight for this side? This size. So I will open the tables for W 16 by 100. So for the sections, 16 by 100. You have 16 here, no? This is 16 by 100. The weight for this member will be 100 pounds per feet. So I will put here 100 pounds per feet. You can put here beside the weight, it's a pound per foot. And you can make it bigger like this. That makes sense? So what is the length of columns? What is the length of your columns? So you are talking about columns of trusses. So I will go to the AutoCAD. Here is the trusses. We have one column on this side and another column on the other side. The length of one column is 22.97 feet. 22.97 feet. You can add here the length. It's very important to put your dimensions in feet. Does that make sense? So how many? What is the number of columns? How many numbers of columns? How many columns do you have? For each truss, we have two columns on the two sides. One on this side and one on the other side. So we have two per truss. How many trusses do you have? Your trusses starting at axis 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. So we have 5 trusses. Each truss has 2 columns, so the total number of columns will be 10. That makes sense? So what is the total weight? And this total weight will be in pound. This total weight equal the weight per unit feet time the length for each column time the number of columns. The number of columns. Enter, I need 22,970 pounds for columns of trusses. Does that make sense? If we will talk about the second part, columns of frames. So you can make match properties, highlight this cell using format painter and put it here and write columns of frames. What is the member size? The member size here is W 18 by 130. You can make copy and put it here. You can make match. Here you go. What is the weight for this size? Member size. If you would like to repeat these titles, that's fine. You can make copy and put them here. Very easy. So what is the weight of 18 by 130? 18 by 130. Go back. 18 by 130. This one. So 130 is here. The weight is 130 pound per foot. What is the length of each column? Each column, open your AutoCAD file for the frame. We have here the frame. We have 2 columns on the 2 sides. And we have one more column here. So be careful. For each frame, we have 3 columns. Each repeated frame. We have the 2 columns at the 2 sides and one more at the intermediate distance. This side has a length equal 32.8. And we have another 32.8 on the other side. And if you measure the length of this column, can make match here, 39.47, or you can add this distance plus this one. It's up to you. So we have three distances. If you would like to take each alone, if you would like to add them together, that's fine. So I will put here equal what? 32.81 plus 32.81 plus 39.47. Enter, you have the total lengths of columns per one frame. Does that make sense? This is the total lengths for the columns, this one plus this one plus this one for one frame. How many frames do you have? We have frames starting from 55-66, 77, 88 until 11. So we have 1, 2, 3, 4, 5, 6, 7 frames. We have 7 frames. Does that make sense? So the total weight will equal this weight time this total lengths for one frame time number of frames equal, I need 95,631.9 pounds. This is just only columns for frames. So please be careful. What lenses did you put here? Is it the length of one columns or lenses for the 2 or the 3 columns per frame? And then you can decide how many numbers will be repeated. In this one, this is the number of columns. In this one, this is the number of frames. You can adjust it. This is the number of frames. Because this is the total length of columns. That makes sense? The next part, rafter of frames. Do you have a question?
Yeah, we didn't account for the columns that are running the other direction.
This one?
Yeah, all them center columns.
I'm sorry?
Yes, all them columns you're highlighting now.
We have another columns for section for axis 11, but this is the name of these columns is different, which is called end gables. We will count them later.
Oh, okay, thank you.
Okay, so I'm working step by step to avoid forgetting any. This is the best way. Step by step, you have columns. This is for the column, the frame which is already repeated as it is. But in this one, these vertical columns will have different name, which is called end gables. Let me continue. So rafter of the frames. I will make copy and put it here. You can match properties to make this one like this one. If you would like to copy these and put them here, what is the member size for rafter of frames? It's a given W16 by 100. What is the weight? We find the weight before, it's 100. What is the length of rafters? You can adjust this name and say it's rafters. Go back to the frame. Rafter means this inclined member. This one and this one. This is called rafter. This one and this one. The inclined beam. It's a beam, but it's called rafter because it's inclined. So how can I figure out the length of this rafter? It's up to you. You can calculate it or dimensions aligned. You can measure from this corner to this corner will give you the dimension. If the dimension did not show up, you can make match properties. What you mean by match properties? Select something it's clear for you and use this match properties and adjust this one. It will be the same format. So the length of one rafter is 67.08. This is the length of one rafter. One rafter. We should have another one on the other side, the same length. If you would like to check, I can show you So the dimension of this one to the corner will be the same dimension, 100%. Here you go. Okay. So the length almost the same, 67 point something. So I will count only one in the length. How many times this rafter is repeated? For each frame, we have two rafters, one on this side and one on the other side. And we have how many frames we have? We have 1, 2, 3, 4, 5, 6, 7. Looks like we have 14. So number of, this one will be a number of rafters. It's 14. That makes sense? So the total weight needed for this rafter will be this weight time the length of one rafter time how many rafters do you have? I will need 93,912 pounds. Does that make sense? The next part is truss members. I will show you something fantastic right now. Truss members. So make match here for the truss members. What is the member size? The member size for these truss members, double L or double angle, 6 by 6 by 0.5. Double L, double angle, 6 by 6 by 0.5. What is the weight pound per foot? I will open the tables of steel, go down 4 angles. Go down 4 angles. Here you go. And I will look for 6 by 6 by 0.5. 6 by 6 by 0.5. Here you go. We have 6 by 6 by 0.5 here, but this page will not give you the weight. We have another page here, which is giving you the weight for 6 by 6 by 0.5. The weight will be this value. 19.6 pound per foot. 19.6 pound per foot. So it's 19.6 pound per foot. Here you go. What is the length of truss members? I need, this is the truss, and these are the truss members. This one, the bottom one, and all of these diagonals and the vertical member. All of them are called truss members. I can copy them outside if you want. Looks like I forgot this one. Here you go. These are the truss members. These are the truss members. Keep in your mind, on this side, we have the column. I don't care about this one right now, and this one is the columns. To format or to create your truss. I don't care about these members because I already counted them in the truss members, in the truss columns. My concern is these members are called truss members. These members will be created from double angle 6 by 6 by 0.5. The weight for each unit feet is 19.6. Can you tell me what is the total lengths of these members? Wow. How can I measure these lengths? Because this one has different lengths than this one, different. Each diagonal has different. Even the vertical members are different. Oh my goodness. I will measure all of them. Okay. I will show you something fantastic on AutoCAD. First of all, the total dimension for this horizontal member is easy. And the total dimension for this one is easy. And this one is easy also. I can make match. Here you go. This one and this one. So we have the horizontal member has a total length 131.883. So here I can put 131.83. This is the horizontal member. This inclined member 65.93. We have 65.93. And we have another 65.93 because we have this member, this one, and this one. So far, so good. I am done with this member. I am done with this member. I am done with this member. Right now, I have issue with these members. Does that make sense? How can I measure out the total length of these members? If you are familiar, good with AutoCAD, we have an command called polyline. If you call this command polyline and going through these members as one unit, like I'm doing, just click at each corner. Click at each corner. This command is called polyline. It's a line, but with different features. Here you go. Then escape. Then I will move what I draw outside. Okay, so what is the difference? What's the difference between this one and this one? The first one, which is the original, each segment alone. But the new one, the whole lines as one segment. We have command called list, L-I-S-T. Enter, just select this object and enter. AutoCAD can tell you what is the total length for this object. This total length is measured in millimeter because the AutoCAD drawing is drawn in millimeters. So just copy it, open Google file, how to convert it from millimeter to feet, put your number here, it's 408.8 feet. You can put this number here. It's very easy. One more time. One more time. Guys, just a second. To let AutoCAD help you to figure out the total length of these members, what I did, looks like I have a technical issue. Just a moment. There you go. So what I did, I moved my diagonal. It's a very hard and time consumer to measure. If you have time, that's fine. Go ahead and find out the length of each member and add them together to find out the total. But I have another option. Go ahead and draw using polyline and move forward on these lines, the vertical and the diagonal. One shot. That means this new draw is one object, one unit, but the old one is individuals, line by line. This is the reason why we need to draw one object, one unit. Does that make sense? Then we have command called list, L-I-S-T. Enter, select your object, enter, AutoCAD will give you the length of this object. Because this drawing is made using millimeter units. Yes, I know the dimension showing feet, but the actual drawing is made with millimeter. So the AutoCAD give you the total length of these members in millimeters. So I opened Google and I converted from millimeter to feet. So the total length of these members, 408.8 feet. And also I forget to consider this one, the vertical member. To make sure you draw polyline as one unit, I skipped this vertical member. This vertical member has a length. I can measure it alone using dimension from this one to this one. It's 13.12. These are the total lengths of the truss members. The first one was the horizontal member, this member. The next two, 65, 65 are this member and this member. The next one, 408.8 approximately, are these members, without considering the vertical one here. So the vertical one is 13.12. This is the third one. So using your calculator, equal sum, I have function in AutoCAD, sum, add them together, enter. This is the total number or the total lengths of the truss member, 685.6 approximately. Does that make sense? This is the total lengths of the truss members. Only one truss, one truss. Your truss is repeated how many times? 5 times. This is the number of trusses. Then the total weight will equal the weight per unit feet time the total lengths of the truss member for one truss time the number of trusses. This is the total weight, 67,188.8 pounds. That makes sense? So you have some powerful AutoCAD. Don't use your calculator, don't use anything, just use AutoCAD. You should be aware of AutoCAD. That makes sense? This is the truss members. We have purlins. The next part is the purlins. The size of these purlins, channel 6 by 7. You can make copy from these titles and put them here. What is the weight of this channel? MC 6 by 7. MC 6 by 7. So I need to look for channel. Here you go. We are looking for MC 6 by 7. MC 6 by 7. Here you go. This one. So this one will be, here you go. The weight is 7 pounds per foot. 7 pounds per foot. What is the length of the purlins? If you remember, your purlins for the trusses and for the frames are these pink lines. These lines. So we have purlins for the trusses and we have purlins for the frames. But both of them the same section, so I can measure out the total length for one purlin. So the total length from this point to this point will give you the total dimension. I can adjust it, match for this dimension. It's 183.63. This is the total length for one pink line from the beginning to the end. 183 0.63. And this pink line, which represented the purlins, is repeated how many times? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and we have 11 on the other side. So these purlins are repeated 22 times. So the total weight will equal the weight for unit feet times the length for one purlin times the total number of purlins, 22, will give you 28. This is the number of purlins. That makes sense? This is the total weight for the purlins, 28,279 pounds. The next part is the end gables. End gables. I will copy these titles here. What is the member size for the end gables? W10 by 30. What is the weight? Open your table, 10 by 30. Go up for the W, 10 by 30. W, 10 by 30. I think it's around here. Here you go. I think, here you go. 10 by 30. The weight of this member is 30 pounds per foot. What is the total length for one member or whatever? Let's see. The end gables represent these columns for the truss. We have 1, 2, 3, 4, 5, 6, 7 columns, intermediate columns inside the truss. And these end gables only at axis 1, 1. Here, at axis 1, 1, these columns, this one, this one, this one, this one are the end gables. Does that make sense? So, I have, what is the length of one of them is 16.4. This dimension for one of them, 16.4. So I have 16.4, and this length is repeated how many times? 1, 2, 3, 4, 5, 6, 7 times. 7. This is for truss. For frame, for the frame, we have these end gables, V3 and V3. Unfortunately, each one has different lengths, so I have to measure each one alone. Draw, dimension linear between this point and this point. Between this point and this point. Between this point and this point. I can make match for these dimensions to show up the same properties. So the first column, 34.1. 34.1 repeated 2 times. Why? Because this column will be the same like on the other side, exactly the same. Second column, 36.07. 36.07 repeated 2 times. And 37.52 repeated also 2 times. 37.52. Is it correct? 37.52. Yes. Repeated 2 times. So what will be the total lengths of these end gables for the truss? All of them the same lengths. You are lucky. This one, like this one, like this one, like this one, because the end gables only until this level. This is the end gable, this is the end gable, this is the end gable. You see, until this level only. So all of them with the same length, 16.4. So all of them counted 7. But for the frame, they have different sizes. This one, different than this one, different than this one. But each one, this one is repeated on the other side, and this one is repeated on the other side, and this one is repeated on the other side. So the total lenses will equal this one, this lens time this lens, plus this lens time this lens, plus this lens time this lens, plus this lens time this lens. Enter. This is the total lenses of these end gable, 330.18. How many times? Only one time. Number of end gables. Because I already counted the whole lenses. So I don't need to repeat them because they are not repeated. Equal this weight time this total lenses, and the number of repetition equal 1. So the total weight will be 9,905 pounds. This is for end gables. The next one, side girths. For the side girths, the size is 6 by 7 also. So 6 by 7 channel with a weight 7 pounds per foot. What is the length of these members? Side girths are, the side girths are this horizontal member, and this horizontal member, and this horizontal member, and this horizontal member from the frame. This frame, and also these horizontal members, and also these horizontal members. These are called the side girths. Side girths. Does that make sense? So how can I measure the lenses of these members? You can copy them outside. There you go. And you can find the lenses of these members. I can tell you the dimension of this one equal how much? 131.23. And this one is repeated how many times? Using AutoCAD, this is the first one. 2, 3, 4, 5, 6, 7 times. So it's repeated 7 times. And what is the length here for this member? It's 53.09. How many times is repeated? We have 1, 2, 3, 4. Then the total lenses equal this one times the number of repetitions plus this one times its number. So the total length will be 1,130.97. The number of side girths will be 1 because I consider the total lenses of all members. So the total weight will be this one time number equal this. That makes sense? Bracing. Do you remember the bracing? Copy. What was the size of the member? I'm gonna use double angle 5 by 5 by 0.5. So open your table. So angles, go down more time for angles. 5 by 5. There you go. We have 5 by 5 by 0.5, this one. But this page will not give you the weight. This one will give you the weight. 5 by 5 by 0.5, the weight equals 16.2. 16.2. Just a reminder, the bracing are these crosses. These crosses are the bracing, horizontal bracing. And these crosses, the V shape or crosses, these are the vertical bracing. Vertical bracing. So let's start with the horizontal one. What is the length of this member? This dimension equal 22.54. 22.54. This member is repeated how many times? This one is bigger. This one is smaller. This one is bigger. Looks like we have 1 by 1. So this one is repeated. 1, 2, 3, 4, 4, and the 4 on the other side. It will be 8, 16, 24, 32. So this member is repeated 32 times. One more time. What is the dimension of this bigger line? The dimension here, please don't forget any. This dimension equal 26.91. 26.91. This member is repeated 2 times here and 2 times here. So it will be 4 times also because we have 2 on the other side. So we have 2, 2 and 4, and we have 2, 2 and 4, so it's 8. Another 8, 16. Another 8, 24. Another 8, 32. So these members are repeated 32 times. Does that make sense? And for these members, what is the length of this inclined one? Dimension aligned between this point and this point. This dimension is 23.99. How many times this one is repeated? 1, 2, 4, 6, 6, 8. Does that make sense? This is 8 on this side, I. So these members are repeated 8 times. What else? We have this V shape. So let me check what is the length of one of them. The length is 11.29. How many times is repeated? We have 2, 4, 6, 8. This one is a little bit different. 8. So let's do it 8. Unfortunately, I have to measure this one separately. What the length here? And what is the length here? So we have 13.46. How many? 2, 4. And this one, 11.1, repeated 2, 4. How much? 11.1. Repeated 4 times. These crosses, this one and this one, I have to count them. dimension aligned. The dimension of this one approximately equal 23.75. And these crosses repeated 4 times. Or these members, I'm sorry, these members repeated 4 times. And what I did here, it should be the same on the other side. I will assume it's the same on axis AA. So all of these will be repeated one more time on the other side. So the total lengths of the bracing will equal this one time this one plus 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 this one time this one equal, this is the total length, 2057.88 feet. Number, this is the number of bracing. Since you got the total length, so the number will be 1. The total weight will be this weight time this total length time number of repetition 1. This is the total weight for bracing. Next part is talking about footing and the corrugated sheet. Footing and corrugated sheet. I will leave it for you, because if I did both of them, that means I solved the project. Does that make sense? Footing is very easy. If you have column, we have footing. Does that make sense? If you have a column, we will have a footing. All of these shapes represent columns. So you can count how many columns by counting how many these symbols. Each column will have a footing. So the dimension of the footing is given. Number of columns, you can figure this out. You can find out the number of footing and how much concrete you need, how much steel reinforcement you need, and all of this stuff. Corrugated sheet. As you remember, corrugated sheets covering the top surface of the floor or the roof. So what is the area? It will be this inclined length, 67.08 by this total length, which is 183, will give you the total surface area of the inclined surface. Does that make sense? So keep in your mind, in your report, final report, don't submit this Excel file. No, you need to open PowerPoint, you need to open Word, you need to open whatever you want, and start to prepare your report. First, cover letter, your name, the name of the course, the name of project, and what is the project is about, and show me the layout of your project. So copy this drawing on your report, and then you can put the design table for you each component, and then you need to answer each question. Does that make sense? So I need detailed calculation on your report. By the end, you will convert your Word file to PDF and submit the final PDF file. Does that make sense? If you would like, you can make copy. For example, columns of trusses and the frame, you can highlight them and make copy and go to the Word and right click, you can bid them paste. Does that make sense? So you can take results from the AutoCAD, Excel files to your final report. But don't just throw the Excel file to me and say, hey, this is my estimate, or this is my cost estimate. No, I need you to answer each question in your problem statement in your report. You can take picture from the AutoCAD file. By the way, if you would like to change the background from tools, options, and we have here colors. You can change the color background to be white. Then we have something called the snipping tool. S-N-I, you can find it, snipping tool. Then you can make new and highlight this one, for example, and make copy. Go to Word file, you can put it here, and the same for this one. If you would like to copy this table, for example, snipping tool, new, and highlight this table, and make copy, and go to the Word file, and you can put it here. That makes sense? And you can write. This is Word. And these are pictures from AutoCAD, from Excel, from Google, from whatever you want. But I need a final report because I will grade it based on the quality. I don't have final answer for this one. I don't care about these numbers. Actually, I don't care. But there's some numbers are logic. That's fine. But my concern is, what is your final product? How, as engineer, as estimator, how you will prepare your final report. So you can take copy from Excel. You can take copy from the AutoCAD file using the snipping tool. It's a Windows tool. Will help you to grab a picture from any window. Anybody has any question about the project?
You have a question about the
Yeah,
total
make your voice high, please, louder.
the total volume of soil excavated. I don't have any information on.
It's a good question. If you don't have any information about this, the typical method in this way is I will excavate exactly with the same size of the footing. And I will use, this is not professional, but this is the only way right now. I will use the soil around this excavated area as your formwork. So I will excavate from the soil exactly with the same dimensions of the footing 6 by 6 by 2. Then I will pour concrete inside the soil. Does that make sense?
Yes, sir.
If you don't have enough information, this is a way to pour your concrete footing. You are going to use the soil around this area or around this volume as your formwork to support your concrete. So the volume of soil excavated will be the same volume of pouring concrete. Exactly. And if you are missing any, go ahead and assume any missing data. If you don't like my way in construction, okay, you can say, I will make the excavation bigger. I need to excavate a footing with 6 by 6 by 2. I will make the excavation maybe 10 by 10. I will leave 2 feet in this side and another 2 feet on the other side. It's fine. That's fine. No problem. Nobody can say it's wrong. But this is how you will construct your footing. Does that make sense?
Yes, sir.
You can assume any logic missing information. That's fine, no problem. But just tell me what you assumed.